Hi everyone. In this video, we're just gonna continue on looking at a few more typical mechanics problems. Once again, exactly the same thing as last time. We're just gonna decompose the forces, calculate reactions, and all that stuff. Okay, so first one, you guys can see this is the bike handle, and this is the handbrake. Handbrake lever, when a force applies to it, it pulls on the cable and applies the brake to the bike. Now, obviously, a good thing to do is always to do a free body diagram. So like we simplify things. As you can see in this diagram, there are quite a few things going on. So let's do a free body diagram to simplify things a bit. All right, it's not very good, but that's good enough. All right, so what are the forces? As you can see here, we have a actually pressing the lever, and of course it's 81 millimeters from the handle, sorry, from the pivot, and then there's also a tension on the cable, which is here is 15. Okay, so what's actually happening? You can see that with the handle pivoted at this point, when the force is applied, it will try to rotate clockwise. Yeah. The only reason it's not rotating clockwise fully, it's not reason it's not start spinning, is because the tension here times the length of the arm, the force arm here. So T times 15 creates a moment that goes the opposite direction, goes counterclockwise, which cancels out the clockwise rotation caused by the 110 Newton force. So that's our equilibrium. Yep. So first part one. It means if all the moment, the sum of all moments equals to 0, so the thing is not spinning non-stop, it means the moment caused by t times 15, so t times 15 has to equal to 110 times 81. Yeah? So moment going counterclockwise, sorry, has to cancel out the moment going clockwise. So that's very easy to solve for t. So in this case, t is just 110 times 81 divided by 15. So t should be equal to 194 newtons. So that's it. Pretty straightforward. Now we need to find the diameter of the cable if the tensile stress cannot exceed 52.5 megapascals. So what is stress? If you remember, stress is a force divided by area, isn't it? So it's basically the unit, like amount of force on each unit of area. Okay, hey, what's the force? The force is 594 newtons over. Sorry. Yes, we have the sorry. Well, we do have the stress here. The maximum stress is 52.5 megapascals, and the area we don't know, so we'll leave it as A. So what's happening here is I'm leaving force as 594 newtons, and the stress as megapascal, because if you remember the unit conversions, with a force, if I have a Newton over area in square millimeters, it's actually equal to megapascal. So a pascal is 1 Newton over 1 square meter, and 1 Newton over 1 square millimeter is a megapascal, because there is a million square millimeters in a square meter. So what do? We solve for A. So A should be 594 over 52.5. So A should be approximately 11.315 square millimeters. Alright, so this is the area, and from the area we're gonna find what the diameter is. Sorry, yeah, diameter. So A equals to pi r squared, which means 11.314 equals to pi r squared. So r squared equals to 11.314 over pi. And so r should be approximately the square root of that. So that's so square root of 11.314 over pi. So that's approximately 1.9 millimeters, which means the diameter will be double that, which is 3.8 millimeters. Yep, so that's the diameter. Now, reaction at the pivot. So if you look at the pivot, so we have two forces. So we have a force going this way, 110 newtons. Yeah. And then another force, tension going up. Yeah. 594 newtons. So these are the two forces that can be transferred, because these are horizontal and a vertical force. So you can actually slide them across and apply to the pivot. Those are the two forces of pivot, and their resultant is this one, isn't it? So their resultant, R, is this force, and we need to find what R is. So obviously, vertical, horizontal, these two sides, we apply Pythagoras theorem. So R squared equals to square root of 594 squared plus 110 squared. So in this case, R is approximately 604.1 newtons. And we can also, to find the reaction, we also need to find a angle for it. So what's the angle? As you can see here, vertical, horizontal, opposite. So if you really want, you can transfer it here. It's probably easier as well. So 594. Yeah, you can see that 594 here. So it corresponds to our right angle triangle. And for the angle itself, angle theta, as you can see, opposite, adjacent. So it's tangent, isn't it? So tangent of theta has to equal to 594 over 110. So theta should be tangent inverse of that. So theta should be approximately 79.5 degrees. Yeah, so that's our answer. Yeah, so let's check everything. So we have the tension. Yeah, we also find the diameter, and we found the reaction. Okay, so next one. Okay, next one may initially look complicated because what's actually happening here? Well, the easiest thing to do is to actually decompose all the forces, because the diagram is quite simple. So I think I can get away with just drawing on the diagram rather than actually do a separate free body diagram. So so what are all the forces? So all the forces we have here is, of course, here's one downwards, mg, yeah. Okay, and then there is a normal force at this wheel, isn't it? Because the wheel is leaning against the slope. So there should be a force like this here, yeah, which is perpendicular to the slope itself. So let's just call it R for normal reaction. Yep, reaction. And of course, we have a force P. So there are the three main forces being applied on this mower. Now, how do we what do we do next? How do we find what P is? Well, we should recognize that the mower is held at rest, so it's not moving up or down, left or right, which means all of these three forces have cancelled each other out. So the whole thing is in a state of equilibrium. That means if P and R, if the pull and the normal reaction are at angles, and then we can break them down into the components, vertical and horizontal components. And all the vertical forces in the whole system should cancel out so that the mower doesn't move up or down. And all the horizontal forces should cancel out so the mower does not move left or right. So let's decompose P and R now. Okay, I'm just going to do it anyway. It's fairly inconsequential, really. So we have a vertical component of P. We have a horizontal component of P. So this one should be, the angle here is 49 degrees. So 49 degrees. So of course this is the it's the opposite side. So it should be P sine 49 degrees. This is the, so let's zoom in a bit. This is the horizontal part, so it should be, this is quite ugly. Let me, okay. So this should be P sine 49 degrees. And this should be P cosine 49 degrees. Similarly, we can do the same to R. Yeah, so we have to find a vertical component and a horizontal component for R. Now, what's the angle here? Well, the angle here, so if this is 65 degrees, if we transfer this, it's 65, and this is perpendicular. So this angle here should be 25 degrees. Yep. Now, what's the upward force? The vertical one should be R sine 25. Yeah, vertical, it's the opposite side. And horizontal, it should be R cosine 25. Yep. So now we have all the forces. mg going down, P sine 49 and R sine 25 going up as well, and the P cosine 49 going to the left, correction, going to the right, and R cosine 25 going to the left. So we can tally up all the forces. Now, if all the forces in the horizontal direction equal to 0, we have P cosine 49 has to equal to R cosine 25 degrees. Yep. Now, in the vertical direction, if we tally up all the forces, so mg, so mass is 45 kilograms, g is 10, then we have, it's approximately 10 really. 450 has to equal to R sine 25 degrees. Yep, so this one plus this one plus P sine 49 degrees. Yeah. Of course, once again, we have two equations with two unknowns, so we are going to solve them simultaneously. So what's this? Because we want to find what P is, so I'm just going to express R in terms of P, isn't it? So I can get rid of the R here. So let's call this equation 1, equation 2. So R equals to, well, P cosine 49, because we divide both sides by cosine 25, so cosine 25 degrees. Yeah. And of course, we can substitute in here. So 450 equals to P, because we're replacing R with this whole thing. Yeah, because that's what R equals to. P cosine 49 degrees over cosine 25 times sine 25 plus P sine 49. Okay, so of course we know sine over cosine is tangent, so 450 equals to P cosine 49 degrees tangent 25 degrees plus P sine 49. And of course we can factor out the p's, so 450 equals to P times cosine 49 degrees tangent 25 degrees plus sine 49. Yeah, and then we divide both sides by this one, so P equals to 450 divided by cosine 49 degrees tangent 25 degrees plus sine 49 degrees. So if you punch all of this into your calculator, P is approximately 424.27 newtons. So here is the answer. As you can see, this is very similar to the one we did yesterday. Only difference are the direction of the forces. And so there is that.